All right, everybody. So in this video, we're going to be covering fuzzing. Fuzzing is very similar to spiking in the sense that we're going to be sending a bunch of characters at a specific command and trying to break it. The difference is with spiking, we're trying to do that to multiple commands to try to find what's vulnerable. Now that we know the trun command is vulnerable, we're going to go ahead and attack that command specifically. So a couple housekeeping items. We're going to go ahead and boot up Immunity Debugger again. So we're going to administrator. And we're also going to run Vuln Server as administrator. So from here on out, you can assume that Vuln Server is going to be running and Immunity is going to be running, and then we're going to have it attached. So let's go ahead and show that process one more time. And anytime that you do crash Vuln Server, we're going to go ahead and restart it and restart Immunity as administrator and reattach. So there are issues sometimes where if you crash Vuln Server and then you try to reload it with Immunity already open, it causes issues. So it's best to just close out of Immunity as well, reopen Immunity, and start it again. So let's go ahead and make sure everything's running. It is in the corner. Okay, so let's go to our Kali machine now that we have this out of the way. And I've built out a script in Python that we're going to use to fuzz. Let's go ahead and take a look at that script. So we're going to say gedit. I called this one.py. You could do that as well. And if you want to pause the video now and write this out, copy this down, that's fine. You could also do it while I'm talking if you want to save some time. So I'm just going to go line by line and kind of talk about this code, and then we'll see what it does. So from the top, we're just declaring that it's Python. We're going to import a few modules here. We're going to import sys and socket. That way that we can call out the specific IP and port. We're also going to import sleep. That way we can sleep it for a second before trying this process over again. So with those imports out of the way, what we're really focused on is we're declaring a buffer variable here, right? So this variable is called buffer, and inside buffer we have 100A. So we've got this A times 100. So what we're going to do is we're going to say while true. So we're going to loop this, right? We're going to say while true, I want you to try something. What we're going to try is we're going to try to connect to this socket. And the socket, all that is this AFI net, that's your IPv4, and the sock stream, that's your port. So we're going to say, hey, let's connect to this IP address. Remember, this is my IP address for my Windows machine that's running Vuln Server. So we're going to connect to this IP address, we're going to connect to this port, and then once we do that, we're going to send over a trun command. Remember, we spiked the trun command, found it was vulnerable, and when we spiked it, when we looked at the registers, we actually saw this little bit of extra information here. So we've got this little command that goes after the trun that needs to go in there in order for the program to actually understand it. So that's why this has been added here. So we say, hey, send over this message, send over trun, and then also send over the buffer. So send trun with 100 A's. Okay, then close that connection, go to sleep for a second, and then we're going to append to buffer another 100 A's. So what we're going to keep doing is as long as there's a connection here, we're going to keep sending you buffers. And it's going to get bigger and bigger. So next time we're going to send 200, then we're going to send 300, 400, etc. until this thing breaks. So what we're trying to do is we're trying to really narrow down where it's breaking and at what specific byte size. So what we're doing here is we're going to fuzz it. And then once it breaks, it should print out an exception that says, okay, fuzzing's crashed at X bytes, right? So let's go ahead and see what that's going to look like. So go ahead and save this file if you haven't already. One other important thing we need to do is we need to change the mode on this to execute. So we'll say change mode +x 1.py. That way we can execute this. And just again to confirm, we've got Immunity running. So let's go ahead now and say 1.py, hit enter, and you should see the connections coming through here on Vuln Server. So every time it's doing this, it's sending a new 100 bytes. We can watch Immunity for the crash. The crash should happen pretty quick. And then once it does, you can kill the program because sometimes it doesn't kill itself. So it's not the best. There we go. We paused it. No more connections. So let's go ahead, go into Kali, hit Control-C, and we crashed somewhere around 2,700 bytes, give or take. Okay, so let's look at the crash. So again, we see the crash came through. and we've got a bunch of A's sitting here. We didn't look like we actually overwrote the EIP. That's fine. We just need to know approximately where we crashed at. So we'll just call it, for even round numbers, that we crashed somewhere around 3,000 bytes. So what we're going to be doing in the next video is we're actually going to be finding where the EIP is at. So how we're going to do that is we're going to use a tool that's going to create these random, not really random, they're cyclical values that we're going to send out. And then we're going to say, okay, what is the EIP value and where does it correspond in the specific number of bytes that we sent over? So remember, controlling this EIP value, let's go back to it. Controlling this EIP value is what's the most important. Once we can control this EIP value, we do a little bit of housekeeping in our exploit development process, and then we point this guy to our malicious code and we get root. So we want this EIP, we want to control it, and in the next couple of videos, we're going to learn how to do just that. So I will catch you over in the next video when we cover finding the offset.